5.8 Indeterminate Forms and L'Hopital's Rule. Problem number 3 says, evaluate the following limit. The limit as x approaches infinity of the quantity 2x plus 5 divided by the natural log of the quantity of 4 plus 2 to the power of, problem number 3 says, evaluate the following limit. The limit as x approaches infinity of 2x plus 5 divided by the natural log of 4 plus 2e to the x. And so the first thing that we should check is that does limit as x approaches infinity of f of x divided by g of x equal 0 over 0 or infinity over infinity. So our first thing is to check if this is true. Well, when we plug in infinity, we would get infinity over infinity. And so this statement is true. This is the form. And so now the second part of L'Hopital's rule says, well, if this is true, then we can take the derivative of x and the derivative of g and if this is in this form, then it would repeat. If it is not, then it would stop. And so let's find f prime of x and g prime of x. Well, f prime of x is f prime of x would be just the derivative of 2x plus 5, which is just 2, divided by g prime of x, the derivative of the natural log of 4 plus 2e to the x. Well, using the chain rule, we can say this is the same as 1 over 4 plus 2e to the x times 2e to the x. And so this would just be 2e to the x divided by 4 plus 2e to the x. And so this was in the denominator. And so when we simplify this, this is the same as the limit as x approaches infinity of 2 times 4 plus 2e to the x divided by 2e to the x. Well, these 2's would just cancel, and we're just left with the limit as x approaches infinity of 4 plus 2e to the x divided by e to the x. Now, let's check this first condition again. When we plug in an infinity to both of these, do we get infinity over infinity? And the answer would be yes. So this was me using L'Hopital's rule here. Now I'm going to use L'Hopital's rule again. And so I'm going to take the derivative of the top and bottom again. And the derivative of the top is just 2e to the x. The derivative of the bottom is just e to the x. And we see that the e to the x's cancel, and we're just left with the constant 2. And so the limit of this function as x approaches infinity approaches 2.